Okay, the next group we're going to call, and again, these are all substitute groups, it's called an amine. It's derived from ammonia, which is NH3, but it actually produces NH2 because it has to be attached, so it loses a hydrogen. But there's actually several different kinds. There's a primary, which has one R group, one chain of like ethyl or methyl or whatever. There's a secondary that has two R groups and one hydrogen, so it's in the middle. So you'll have your NH in the middle, and then you'll have two R groups attached to it. And then you have one with three R groups, and again, this one's pretty rare. This is actually the most common, and this isn't that uncommon either. And again, I'll show you how to name them. They all have their own ways of naming them. Since they come from ammonia, ammonia is NH3. It has a lone pair, so it's going to have, it's kind of like a tetrahedral shape, but it's really trigonal pyramidal, if you remember, because it squishes the lone pair, squishes it a little bit closer together. But since it's derived from that, it replaces the lone pair, and you end up with that tetrahedral shape. Okay, and if you have a primary or secondary, you're going to have a hydrogen bond. And again, remember, that's going to make it a little bit stronger because hydrogen is the strongest intermolecular, in between molecular forces. Okay, and they tend to call them alkaloids. If you've heard of alkali, the base, the stuff that we have in our soils in the springtime, that white stuff, they're very active with that. Okay, so I'm going to put all this because it doesn't make sense until you see one. All right, so if I'm going to name an amine, okay, I'm going to assign the root name. This is that the ending is amine. Anytime you have this NH group, it's an amine. Okay, the locator number, well, in this case, it's on the end, so it's going to be 1. You don't have to write a 1. And then you have your chain. Okay, this chain, there's 2. 2 is eth, and it's a substitute group, so it's ethyl. So this would be called ethylamine. That's simple. So when you name one with just one amino group, which is called a primary, amine goes on the end, and then whatever's over here, if it had 3 carbons, it would be propylamine. If it had 10, it would be duodecyl or whatever it is. Yeah, decyl. That sounds weird, doesn't it? If it was benzene, it would be phenylamine. Okay. Here's another example where now this would be a secondary, where you've got the NH in the middle. Okay. We've got an ethyl group here and an ethyl group here. So here's your NH, that's an amine, and this would be diethyl. There'd actually be one more hydrogen here, you guys. I don't know what happened. I got cut off. But 2 ethyl groups, you wouldn't write ethylamine, you'd write diethylamine. So this is a secondary one. Okay, and I didn't even put in a tertiary. I'm not going to show you those. But again, when you're naming them, amine becomes the main, and then the others become a substitute group. If I had like a propyl group over here, and which would be a chain of 3, and then one of 4 over here, it would be in alphabetical order: butyl, propyl, amine. Okay. All right. What happens if you take off hydrogen and you add a halogen? Because remember, these guys have 7 valence electrons, so they just bond really easy in there. They just need 1. So when you drop off a hydrogen and place it with a halogen, you indicate where it is, and then you use the prefix. The prefix is, if it's instead of hydrogen, it's a fluorine, it'd be fluoro, bromo, chloro, and iodio. Oh, I think I'm missing an I there. I'll have to look it up. Anyway, I just had to add this because I noticed they had these examples, but they didn't have it in the notes, so I just threw this in here. But if you look at this one, 1, 2, 3, 4, that's butane, but we're missing a hydrogen here. We dropped it, so that you could write just chlorobutane because it's on the first one, or you can write 1 chlorobutane. Okay, and again, now if there was 2 chlorine, I'd write 1 dichloro. If there was 4 chlorine, you'd say where they're at. Let's say there was a chlorine here and a chlorine here and a chlorine here and a chlorine here. I'd write, 1 2 2 tetrachlorobutane. So you have to say, just like you did with methyl groups and ethyl groups and everything, just say where they're at. Okay, this one right here, 1 2 3 4. So we know it's butane again, and now it's on the second one. So this would be 2-chlorobutane. Okay. If this was a fluorine group, it would be 2-fluorobutane. So again, you just say where they're at, give them a number, and then if you have more than one, you'd use di or tri or whatever. Okay, so that's, again, if you drop off a hydrogen and throw in a halogen. Okay, So the next functional group is what they call when you have a double bond O. Okay, and these are going to be, there's three of them. There's one where it's two of them are on the end. One of them just has a hydrogen. One of them has a hydroxyl, OH. And then there's one where it's in the middle. Okay, so these are called carbonyl groups, but there's actually three different types of carbonyl groups, and their shape again is trigonal planar because they have three bonded to it. Of the groups that attach to the, there's always going to be this functional group, and then the other is going to tell you what it, if it's a chain of 3, a chain of 4, a chain of 5, and so on. Okay, they do have a polar covalent bond. So they're kind of like, water in that sense. They'll help, with dissolving like ionic compounds and so on. So they do have a permanent dipole. So they do have a strong intermolecular force. Okay. And again, the carboxylic acid is one of the ones we're going to talk about. There's also the amines. We'll talk about them as well. They have a hydrogen bond. So if they have a permanent dipole and a hydrogen bond, they have very, very, very strong intermolecular forces. Okay. So an aldehyde, what happens with an aldehyde is it's on the end and it has a double bond C and then an H. So it's always on the end, which actually would be the first carbon. Okay, so I'm going to put these and show you. Oh, sure, I don't have an example. All right, you're going to sign the root. How many carbons do you have? So let's say you have a chain of 7. We know that's heptane. We're going to drop the E and add Al if it has a double bond OH on the end. And again, I'll show you, this is better. An aldehyde, an example of an aldehyde, if you want, a common one would be formaldehyde. If you ever remember dissecting stinky, the stuff that they use to preserve animals, they use it in embalming and all that kind of stuff. That's an example of an aldehyde. Okay, so here, 1, 2, 3, 4. So that would be butane. Okay, but we have the double bond OH on the end. This is your aldehyde right here. Okay, so instead of butane, it'd be butanal, and this is the first carbon. So if I have substitute groups here, let's say I have a methyl group here, it would be, 1, 2, 3 methyl butanal. Okay, so this is just butanal. It's butane, but we got the double bond O in there, H. So drop the E and write Al, and that tells me I have a double bond O. Okay, on this one, okay, here's a methyl group. Okay, so 1, 2, 3, 4, 5. We know that's penta. Okay, this is a double bond O, so that's the Al. And then I got to say where this group is. It's on the second carbon, so it would be 2-methyl pentanal. You don't put a number for this one because it's always on the first carbon. Always, 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 always. Okay, so again, 2-methyl, this is the methyl group. It's on the second carbon. And then on the first carbon, you have your double bond O, so it's a chain of 5. That's the pent. And then Al tells me it's a double bond O. Now, if I had a triple or double bond in here, again, I could change this to an E and put what number it's on. So let's say there was a double bond right here. So I'd say 2-methyl 3-pentene, and then I'd have the Al on the end of that. So you could change that too. So in the name, you could, again, an E is a double bond, a Y is a triple bond. So you can put those in there as well. They're not very common in the aldehydes. They have double bonds and triple bonds, but you can name them. You can tell where they're at. Okay. A ketone is a double bond O, carbon double bond O, but it's not on the end. So you're going to have two you're going to have two R groups. When they say R group, that's just a carbon chain. On either end. It's not on the end like the aldehyde was. It's in the middle. Okay, and again, you sign the root, you add the ending. It's probably easier for me. The ending of a ketone is ONE. Okay, so instead of like if it was pentane, it would be pentanone. Okay, and then again, you got to say where your carbon group is. You got with a ketone, you have to say which carbon it's on because it's in the middle. It's not on the end. Okay, and there's lots of ketones. Acetone is the most common ketone. It's a fingernail polish remover. Okay. Okay, so on this one, we got 1, 2, 3, 4, 5, 6, 7. Okay, that would be hept, right? 7 is hept. And on the second one, we got our ketone. So this would be 2-heptanone. Okay, 2 tells me that's where the double bond O is. The ONE, I dropped the E in at ONE, that tells me it's a ketone, which is a double bond O. And the second tells me where it's F. Okay, this one, 1, 2, 3, 4, 5, 6. But look at, I got these 2 methyl groups. Okay, so again, I'd go 1, 2, 3, 4. I'd go 3, 4 dimethyl. Okay, and then I got 1, 2, 3, 4, 5, 6. That's hexanone because I got the double bond. So it'd be 3, 4 dimethyl 2 hexanone. I should probably just write that and show it to you. Oh, sorry, I cut off my ONE here. But again, this gets the smallest number. So 1, 2, 3, 4, 5, 6. Hexanone right there. That's these guys. But I got to say where my methyl groups are too. 3, 4. 3 and the fourth is there's a methyl group, so there's 2 of them, dimethyl. 2, the double bond O is on the second carbon. So 3, 4 dimethyl hexanone. Okay, so if it's on the end, the double bond O, that's an aldehyde and it's Al. If it's in the middle, that's a ketone, it's ONE, and you got to say where it's at. Okay, and then the last of the carbonyl groups is called carboxylic acid. Okay, carboxylic acid is like an aldehyde. You have the double bond O and it's on the end, but now instead of just an H, it has an OH. Okay, so again, you assign the root, and now if it has a double bond O, OH, instead of ending with Al or ONO, it's oic acid. Okay, and again, it's the first carbon, just like an aldehyde. So you name it just like an aldehyde, except now it's oic acid. Okay, so I hope you can see these. Oh, this shows you the process of making it. A carboxylic acid, you add water to it, and you get something called an anion. This is, well, I'll show you these later. This is a process called esterification. And it's a common process that we use in making smelly things like perfumes and flavorings. But let me show you. Oh, I hope I have one on here, don't I? Okay. All right. Sorry about that. Okay, so carboxylic acid, again, it's a functional group. It's a very, very, very common. Like they're in fatty acids. So we have a lot of them in our bodies. They're in amino acids. We use amino acids to make proteins. So if you take a carboxylic acid and amine, you'll get an amino acid. Very important. Some of them have multiple carboxylic acids with functional groups. The thing I'm trying to point out here is carboxylic acids are very widely used, and they're really, really important to living things. Okay, they are capable of hydrogen bonding, which means they have a strong bond, and they're used in lots and lots and lots of reactions in your body. So carboxylic acid is a very common organic compound, and here I'll show you how to name them. Okay, so here's the ending, double bond O, OH. Remember, an aldehyde just had a double bond O and an H, but we have a double bond OH. Okay, so we got 2 carbon, that's eth, right? So this would just be ethanoic acid. Okay, 2 carbons, double bond OOH on the end, ethanoic acid. Sometimes they're straight across, sometimes, because they actually do bend like this. That's why sometimes you'll see them drawn that. Okay, here we got 1, 2, 3, 4. Here's our carboxylic acid right here. And it's 1, 2, 3, 4. Okay, so we got 4, which would be butanoic acid. We got a bromo group on the, this is always the first carbon now. So 1, 2, we got bromo. And over here, we have a methyl on the third. Bromo would go first, so it'd be 2 bromo, 3 methyl butanoic acid. Okay? Again, it's just telling you where everything is. This is always the first carbon, double bond OOH. You can write it this way or this way. But again, that's a chain of 4. That's the butanoic acid. You don't have to put a number because it's always on number 1. Well, we have this bromo group and this methyl group. Well, alphabetical order. On the second one, we have a bromo. On the third, we have a methyl butanoic acid. That's how you name it. Okay, so whenever you're naming these, okay, you have to go in order. I'll give you guys a sheet that has all the functional groups. You don't have to memorize them. You'll have them in front of you anyway. But it'll help you when you're trying to figure out, oh, double bond OOH, what is the ending? Oh yeah, oic acid. You don't have to necessarily memorize them all. They'll be there for you. And we're pretty much out of time, so we'll quit here, and then next time we'll pick up with some more.